back to another class of physics for class 7, and the topic today is measurement. So we've been studying on the same topic for the last few classes, and today, in the last class we discussed about mass and weight, and today we'll be discussing about a new topic, and this might be a new term for you all, which is called density. Okay, density comes from the word dense. Now you know what dense means. Okay, it is related to the word dense. Now you know what the word dense means, isn't it? If I say dense forest, what does it mean? Forest which has a lot of trees. If I say dense population, which means a lot of population. So when I say dense, it means a lot. Okay, so when I say density, when I'm talking about density, it means a lot of particles present in it. So a lot of so if I compare the density, if I compare this to say I have to compare a box full of chalk and this duster. Now the duster feels lighter compared to this one. Okay, you might not consider because this looks like a paper box, but it has a lot of chalk over here. So when I compare this, which one feels heavier? For me, this one feels heavier than this one. So why do we say this one feels lighter and this one feels heavier? It is because the matter present in this is more than this. Okay, which means the particles are more denser here than this one. Similarly, if I compare a plastic chair and a wooden chair, okay, I can see it over here, so that's why I'm comparing it. If I compare a plastic chair and a wooden chair, which one would be heavier? Obviously the wooden chair. And why would the wooden chair be heavier? Because it has more particles contained in it. Okay, and that's why we say the particles are dense in a wooden chair than the plastic chair. Now, and then from the word dense we come to the term density. But in physics, density cannot be just defined with the particles present in it. Okay, you cannot just see an object. However you can guess, but you might not be able to know actually which one is heavier. Okay, and understand, so we have the right concept. And to understand that concept, we need to know density. And before we continue with density, we need to know the two terms. Which one we have, both the terms we have already been discussed. One is your mass, the other one is your volume. Now density is related to mass and volume. So how do we define density? Density is defined as, mass per unit volume. Okay, density is defined as mass per unit volume. Now what does mass per unit volume means? It means density would be equivalent to mass divided by volume. Okay, so density would be defined as mass per unit volume, and what does it mean? It means mass by volume. Okay, so when you compare the mass and the volume, we get density. Now how are they related? How are mass and volume related? And how are they related, and how would they make a density, isn't it? So, when we talk about mass, you know what mass is, we discussed that earlier. So mass, when we talk about mass, so the particle which has more mass has more density. Okay, which means the particle which has more mass, let me see, not the particles, the substance which has more mass will have more density, which means the substances which have more mass has more dense particles, and thus it has more density. Okay, so likewise when we compare this book, these two different books, okay, if we compare these two books, now you can see this book is heavier than this book, which means this book has more mass than this. So which one will have more density? Obviously the one which is on the left hand. Okay, the one which I am carrying on the left hand will have more density than the one which is on the right hand. And okay, so more the mass, more will be the density. Means more mass, more number of particles would be present, that is more dense particles, thus the density would be more. Now how is it related to volume? So when we talk about mass, when we say a particle which has more volume, okay, say if there are two particles, which have the same mass, but they have different volumes. Let's take cotton. So you have cotton, you take 1 kg cotton, and then you take 1 kg iron ball or any metal ball. Now here I am taking an example. I have taken the mass is same here. What is the mass here? 1 kg, 1 kg. So mass is same, 1, 1. But one is cotton, the substances are different. One is cotton, the other is an iron ball. Now when you see 1 kg iron ball and cotton, now see here, which one occupies more space? Cotton, obviously, which means cotton has more volume. Okay, cotton has more volume and iron ball has less volume. So more the volume, lesser will be the density. Now more volume means the particles are free to move around. Okay, they will not be together. Okay, densely packed together. They would be free to arrange themselves compared to iron ball. So here in iron ball, the particles would be together, that is densely packed, because the volume is lesser. And here the volume is more, so the particles would be free to move. Okay, they will be spread. So that's why we say cotton, when the volume is more, density will be less. So how is density related to mass? When mass is more, density will also be more. Okay, if mass is more, density will also be more. If volume is more, density will be less. So with density is directly related, with volume it is indirectly related. And how do we define density? Density is defined as mass per unit volume. Okay, so I hope you understood this. So mass density depends upon two factors. One is mass, the other is volume. If mass is more, density will also be more. If volume is more, density will be less. Just the opposite. And I told you why. Now since density is related to mass and volume, so when we talk about the SI unit of density, when we talk about the SI unit of density, we take the units of mass and volume. So what is the SI unit of mass? It is kg. What is the SI unit of volume? Cubic meter or meter cube. So what will be the SI unit of density? It is kg per, the slash means per cubic meter, or you can also write it as kg m to the power minus 3. So either one will be correct. Okay, this is the SI unit of density. So what is the SI unit of density? It is kg per cubic meter or kg, and you can write m to the power minus 3. Either one will be correct, and it is pronounced the same, kg per cubic meter. Okay, the smaller units, this is the SI unit. The other smaller unit, if you are measuring a density of a smaller object or substances, then the smaller unit will be gram per cubic centimeter. Okay. So, and I'll be doing one numerical related to it, and which is in page number 27. Okay. Solve the following numericals, which is question number I, sub question number 3. So I'll be doing one numerical related to density question say, I'm doing numericals. Sub question number 3. Question says an object has a mass of 100 gram and a volume of 20 cubic centimeter. What is its density? Which means the mass is given in gram. 100 gram. Okay, and what is your volume? Your volume is given in cubic centimeter, which is 20 cubic centimeter. Now, whenever you're doing numericals, you need to see the unit. This is given in gram, this is given in cubic centimeter. So we don't need to do the conversion here. Okay, we don't need to convert the units. Had this been given in kg, and if this was given in cubic centimeter, then you have to convert kg to gram or cubic centimeter to meter. The unit has to be same. If it's an SI unit, it has to be an SI unit. If it's a CGS unit, all the units have to be CGS. So here, the units are CGS, that is smaller unit. So we have gram and cubic centimeter. So we don't need to do any conversion. So what is the formula for density? The formula for density is mass divided by volume. So how much is your mass? You just put the values. How much is your mass given? 100. And how much is your volume given? 20. So simple calculation. So and how much do we get the density as? 5. And what is the unit? The mass, the unit of mass is gram per cubic centimeter. So this is how we calculate density. Okay. So I want you to do number 4 yourself. An object of mass 40,000 kilogram and a volume of 5 cubic meter. What is its density? So mass is given in kilogram and volume is given in cubic meter. So I don't think you need to do any conversion here because it's given, both the units are SI units, kilogram and cubic meter. So you simply have to put the values and calculate the density, just like this. Okay, so I want you to try number 4 on your own. And the rest of the sum we'll be doing later. So this much for today. If there's any question, any queries, please do call me or text me. And thank you and have a good day.